We started talking yesterday about our silver bullet, chapter 5, quadratic formula.
Yes.
Any quadratic equation written in standard form, so if it's written like this, ax squared plus bx plus c equals 0, where a, b, and c are just some numbers, then we can always get solutions with the quadratic formula. So in certain cases, you don't always want to. In certain cases, it's easier just to factor. If we can point to a single x, remember, we always want to isolate it, so we don't need the quadratic formula then. But otherwise, if it looks like it's going to be difficult to factor or it doesn't factor, then we use the quadratic formula. And let's see if you remember it.
X equals negative b plus or minus square root b squared minus 4ac divided by 2a.
There you go. Okay, good. There you go. You'll never forget it. Okay.
3 years now.
Okay, so if we want, let's take a quick look at a couple examples, and then it's not that big a deal. There's one or two important things I want to mention about this, but putting it to practice, putting it to use is not that big a deal. What must I do here before I can use the quadratic formula?
Subtract 5.
Good. Got to subtract 5 from both sides so it's in standard form. Got to get it equal to 0. Okay, if I do that, then what's A?
2.
What's B?
1.
C?
5.
Just plug them in. No big deal then. If we make those substitutions, all we got to do is the part that's the most difficult and where you're going to want to start, for reasons that we'll talk about in a second, is under the radical. Calculate what you're going to get in there. Now, remember a little rule also that's very helpful. When you're calculating, b squared is always positive, isn't it? Whether you square a positive or a negative, you're getting a positive result. But the minus 4ac part, you got to be a little careful with that. It could be negative, it could be positive. Count the negative signs. Here we've got a negative 4 and a negative 5, right? And that's two negatives makes a positive, right? An even number of negatives makes it positive. So we got 1 plus 8 times 5, 1 plus 40, right? So square root of 41. And they're both my answers, aren't they? Plus or minus, both included in there. So roughly 1.35 and roughly negative 1.85. But better answers. This is a better answer right there, isn't it? That's an exact answer. Okay? But sometimes we want to know basically what's the value. Where is it on a number line? Approximately. Then we turn it into a decimal. Okay? Same kind of thing here. Just subtract 5x, add 9, and plug it in. No big deal. Okay, and notice this time we got a 0 under the radical. Square root of 0 is what? 0, sure. So that's just one answer. 6 over 2 is 3. Okay. Or we could look at one like this. Now with this one, I don't know if they're going to do this one the way I would want you to. So we might take a little deviation and do this our own way. I'd subtract 2 from both sides, right? Okay, now when we're using the quadratic formula and we've got the equation in standard form, this is kind of important. We would prefer not to have a negative number for A. So can you think of something we could do here to change that?
Add it all to the right side.
Well, we could add it all to the right side. That's one possibility. What's the other possibility?
Multiply by negative 1.
Yeah, if I multiply both sides by negative 1, multiplying a string of terms by negative 1, what's it end up doing?
It just reverses.
Yeah, it just changes all the signs, right? And then anything times 0 is still 0. Yeah, I wonder if they'll do that. No, they didn't. So we want to kind of go. We're going to go rogue here and do this on our own. So if we multiply both sides by negative 1, I'm going to get x squared minus 2x plus 2 equals 0. Now, the reason we want to do this is because it's when you're dealing with a plus or minus in the numerator, it's awkward to have a negative answer in the denominator. And remember, we have a 2a in the denominator of the quadratic formula. So we really want a to be positive. We really do. It's helpful. So this would be better. Instead of using those values, we would just pick A equals 1, B equals -2, C equals +2. Okay. That really does help. All right, so I'm just going to skip through this one because I don't want to show you the way they did it. Okay, now this is the other part I wanted to show you. You can make a prediction here. A lot of times you can avoid having to do unnecessary work. If we're wanting to only find the real solutions, which sometimes we are. Sometimes we're really not interested in finding imaginary solutions. We really just want the real solutions. If we're going to do that, when we start off with the quadratic formula, look at the discriminant first, because the value of the discriminant, and that's just the discriminant is the word we give for all the stuff that's inside the radical, the b squared minus 4ac stuff. So that's what we call the discriminant. What's going to happen if that discriminant has a negative value? The b squared minus 4ac. That's the part that's in the square root. Yeah. If I get a negative number for the b squared minus 4ac for the discriminant, then I'm going to end up with an I, aren't I? Because that's going to mean a negative number under a square root. And so we could just stop right there. If we're only looking for real answers, we know that there aren't any and we're done. No, there's no reason to go through all this work. The discriminant makes a prediction. It'll tell you exactly how many solutions you can expect. And it makes sense. This is just total common sense here. If the discriminant is positive, right, if it's bigger than 0, then I'm going to get negative b plus or minus the square root of some positive number. The square root of a positive number is just a number, isn't it? Right? So I'm going to get two answers, one for the plus and one for the minus. Right? Make sense? Like that first example we looked at. We had plus or minus, I think, the square root of 41. Something plus or minus the square root of 41 divided by something else. Two answers. If the discriminant is exactly equal to 0, well, that looks like this second one that we saw. If we go back just a little bit. That one, right? Look what happened here. We had the discriminant ended up being 0, and so we just got, 6 plus or minus 0. Well, that's the same thing, isn't it? 6 plus 0 and 6 minus 0 amounts to just 6. So we only get one answer. If the discriminant happens to be exactly equal to 0, and if the discriminant is negative, then we're going to get no real solutions. We're going to get two imaginary solutions, and they'll always be complex conjugates. Something that looks like a plus bi and then a minus bi. So that's the way quadratic equations always work. We'll get into that in more detail soon. So you know right away what's going to happen. Let's just take a quick look at what these things look like. So here's an example of one that's got, if we go through and look at this, we can kind of skip the work. Well, we saw them. That's all right. I want to show you the pictures anyway. So there's an example of one with a discriminant that's negative. It has no zeros, meaning it has no x-intercepts. Remember that the zeros of an equation, if it's in standard form, if it's set equal to 0, if we find the solutions of that are the zeros, those are just the x-intercepts of the graph. So if the discriminant is negative and there are no real solutions, there are no places on a real number line where the curve crosses the x-axis, no x-intercepts. So either the parabola that's formed by that quadratic function opens up and it's completely above the x-axis, or the other possibility is it could even look like this. It could be down here. Open down and be completely below the x-axis, but it doesn't cross. If the discriminant's exactly equal to 1, like this one was, then it touches in exactly one spot, only at the vertex. So you only get one solution. And then if it's a normal one, we might say, it's got two. If the discriminant is positive, it's going to have 2 x-intercepts. Okay, like ours, I think was, I can't remember what it was, 1 point, well, I don't remember. One of them was positive and one of them was negative in our example, but there'll be 2 alg2 in general. Okay. I think that's good. I think you guys are ready to go. Let's